Have you ever really stopped to think about how all the devices in your home network actually talk to each other? Well, today we're pulling back the curtain on the unsung hero that makes it all happen. It's the silent workhorse of your local network, the data link layer. Let's get right into it.
I mean, really think about it for a second. Your Wi-Fi is probably packed. You've got your laptop, your phone, a smart TV, maybe a gaming console. All of them are connected. How on earth do they communicate without all their signals just turning into a jumbled, garbled mess? How does that print job know exactly which device it's supposed to go to?
Well, the answer is something you can think of as a super efficient, super local postal service. This is layer 2 of the OSI model, the data link layer, and its entire job, its entire world, is handling the mail delivery right there inside your own network neighborhood.
So here's our game plan for this explainer. First, we'll break down what this local postal service really does. Then, we're going to meet the two sublayers that make it all tick. After that, we'll uncover the secret behind your device's unique physical address, see how wired and wireless networks have to play by different rules, and finally, we'll see how modern networks make this local delivery incredibly smart.
All right, let's start with the big picture. What is the fundamental job of this so-called local postal service? What's it really doing behind the scenes?
Now, the key phrase here is directly connected. You got to remember, Layer 2 doesn't care about sending your data across the internet to another country. Nope, its world is small, it's focused. It's all about getting a chunk of data from your computer to your router or from your phone to your Wi-Fi printer reliably and without any errors.
And how does it pull off this reliable delivery? It does it through a process called framing. So imagine the data coming down from the layer above it, the network layer, as just a plain old letter. Layer 2 takes that letter, puts it into a nice, sturdy, structured envelope, seals it up, and then slaps on the very specific local delivery address. This envelope, this package, is what we call a frame.
And a frame is way more than just a simple wrapper. It's a highly organized package. It has specific spots for the destination and source addresses. That's basically the to and from on our envelope. It also carries some control information for error checking, which is kind of like a quality seal that makes sure the letter arrives perfectly intact, with no smudges or tears.
Now here's where it gets really interesting. The data link layer isn't just one single thing. It's actually split into two different sublayers that work together perfectly. You can think of them as the brains and the brawn of the entire operation.
So first up, you have the Logical Link Control, or LLC. This is the software brain. It's the diplomat that talks to the layer above it, the network layer. Its job is to figure out what kind of data is inside that frame. Is it an IPv4 packet? Is it IPv6? The LLC is like the detective, figuring out the contents. Then you've got the Media Access Control, or MAC. This is the hardware brawn. This layer gets its hands dirty. It talks directly to the physical cables and the radio waves below it, and it handles the really tough job of getting the frame onto that medium. And most importantly, it deals with that unique physical address. And that brings us to one of the most fundamental concepts in all of local networking, that physical hardware address. I want you to think of it as your device's permanent, unchangeable, unique fingerprint. This is the MAC address. Every single device that can connect to a network, your phone, your laptop, your smart fridge, has one of these physically burned into its hardware by the manufacturer. Now, unlike an IP address, which can change all the time depending on what network you're on, a device's MAC address is permanent. It's a key part of network security for sure. This is what one looks like. It's a sequence of 6 pairs of letters and numbers. You've probably seen one of these buried deep in your phone or computer's network settings. Well, that is its permanent, physical name on any local network it ever joins. So let's bring it all back to our postal service analogy. The MAC address is the absolute, non-negotiable, permanent house number for your device. When a data frame is sent out on your Wi-Fi, it's this exact address that makes sure it gets delivered right to your printer's front door, and not your smart TVs. Okay, so every device has a unique address. Great. But what happens when the street itself gets super crowded? You know, what happens when dozens of devices are all trying to talk at the exact same time using the same cable or the same airwaves? Well, you need some rules of etiquette. This is the absolute core problem of what we call media access control. If two devices try to transmit at the exact same time, their signals slam into each other and become corrupted. That's a collision. So the question is, how do we prevent this chaos? How do we manage the conversation so everyone gets a turn to speak? Well, we use two totally different strategies, and honestly, the analogies here are perfect.
For older wired networks, the method was CSMA/CD, or collision detection. Basically, a device would listen, and if the line was clear, it sent its data. If it accidentally collided with another device, they'd both stop, wait a random amount of time, and then try again. It's literally like apologizing after you bump into someone. But for wireless networks like Wi-Fi, we use CSMA/CA, or collision avoidance. Here, the whole goal is to prevent the collision from ever happening in the first place. A device listens, and then it basically asks for permission to send. It's like politely asking, "Excuse me," before you start walking through a crowded room.
So, we've got unique addresses, and we have rules for talking without interrupting. But in a modern network, the delivery system is even smarter. It's not a free-for-all anymore. We have these intelligent devices that act as our network traffic directors.
And that brings us to the network switch. I want you to think of a switch as the incredibly smart postal worker at the central sorting office. It doesn't just blindly shout mail out to the entire neighborhood hoping the right person hears it. No way! Instead, it learns exactly which mailbox or which port each house is connected to, and it delivers the mail directly and privately.
And here's its process. It's actually beautifully simple. First, a frame arrives on one of its ports. The switch immediately looks at the source MAC address and thinks, aha, the device with this address lives on port 1. It makes a note of that in its internal address table. Then it looks at the destination MAC address. It checks its table, and if it knows where that device lives, it forwards the frame only to that specific port. Nobody else on the network even sees it.
And the impact of this is huge. By sending frames only where they need to go, switches drastically cut down on all that unnecessary network chatter, which improves speed and performance for everyone. And remember those messy collisions we talked about? Well, a switch basically gives each connected device its own private road, which pretty much eliminates collisions entirely. Plus, it massively enhances security, because your data isn't being broadcast for every other device to potentially listen in on.
So from packaging your data into neat little frames, to giving every device a unique physical address, to managing the rules of conversation and intelligently directing traffic, the data link layer is doing all of that invisible but absolutely essential work that makes your local network fast, reliable, and efficient.
It is the absolute master of local delivery. But what happens when your data needs to go beyond your local neighborhood? What happens when it has to travel across the vast, wide-open internet? For that journey, a local MAC address just isn't enough. You need a completely different kind of address and a completely different kind of postal service. And, well, that's a story for Layer 3. Thanks for watching.
Thanks for watching. Like, share, and subscribe.